An important concept in calculus involves finding what's called the difference quotient. The difference quotient is used in calculus to define what we call the derivative, but in classes below calculus, we just take out the calculus part of it and we only focus on the algebra. So the difference quotient of a function f at x is defined as f of x plus h minus f of x divided by h, where h is not 0. So most people get really confused with the f of x plus h, but it's not that bad. You just gotta take it piece by piece, and you'll see that it's not too terribly difficult. So we have the function f of x equals 4x plus 3. So what we're going to do is we're going to first do f of x plus h. And that just means f of x plus h just means that wherever there's an x, you replace it with x plus h. So in our function, we only have one x. So we can say that 4 times x plus h plus 3. So again, all I did was replace x with x plus h. So in our difference quotient right here, f of x plus h, we're going to write that in. So 4 parentheses x plus h plus 3. So that's the first part here. The next part is going to be minus, so a minus, and then f of x. And f of x here is 4x plus 3. And then you need to do this because it's a very common mistake. Put this part in parentheses. So there is the last part. And then it's all divided by h. Now, we just do the algebra and simplify it. So distribute the 4 across and distribute the negative across. So we're going to get 4x plus 4h plus 3 minus 4x minus 3 over h. Now this is the nice part. Anything without an x or anything without an h should cancel. If it doesn't, you've made a mistake. So the 4x's, positive 4x and a negative 4x will cancel. Positive 3 and a negative 3 will cancel, leaving you with only 4h over h. And the reason why you should have an h left over is because they should cancel out as well, leaving you with only 4. So the difference quotient for this function is going to be just 4. Now let's do it again, except this time it's going to be a little bit harder. So again, f of x plus h is just going to be 3x plus h squared plus 2. Wherever there's an x, it's replaced with x plus h. So now I can plug this into my difference quotient. So it's going to be 3x plus h squared plus 2 minus the function itself, 3x squared plus 2 divided by h. Now, x plus h all squared just means there's 2 of them, so I'll just write that out explicitly. So 3x plus h, x plus h plus 2, and then I'm going to distribute the negative end just to clear that out. So minus 3x squared minus 2, all divided by h. And then we just FOIL out these two parentheses, and we're going to end up getting 3x squared plus 2xh plus h squared when you simplify it all together, plus 2 minus 3x squared minus 2, all divided by h. And now we just distribute the 3 across. So 3x squared plus 6xh plus 3h squared plus 2 minus 3x squared minus 2, all divided by h. Now again, everything without an h should cancel. Positive 3x squared, negative 3x squared, positive 2, negative 2. So we only have these terms that are left over. So I was going to write it down here. So we're going to have 6xh plus 3h squared divided by h. And then everything has an h, so we can divide out an h out of everything. So we're going to end up with 6x plus 3h. And that is the result for this function, for the difference quotient. And last, we're going to do the difference quotient of square root of x minus 2. So again, f of x plus h is just going to give you square root of x plus h minus 2. Now this one's going to go a little bit different, so pay close attention. When we plug this into our function, or our difference quotient, excuse me, we're going to have square root of x plus h minus 2 minus our function, square root of x minus 2, all divided by h. Now, there's really nothing we can do here, so what we're going to do is we're going to multiply the top and the bottom by the conjugate of the top. So when we do that, it's going to be x plus h minus 2 plus square root of x minus 2, all divided by the exact same thing again. Now, why do we do that? You're going to see very shortly. When you multiply the two conjugates together, you essentially only need to multiply the first two terms together and the last two, as the middle two terms will cancel out. The nice thing about doing this is, when you multiply the first two terms, you're just going to end up with an x plus h minus 2. And when you multiply the last two terms together, you're just going to get an x minus 2. Now, in the bottom's a little bit different. You're going to have a lot more. Now, you can distribute the h across, but it's better to not. Just leave it as is for now, and you'll see why in a second. Now, distribute the negative across this parentheses. We're going to get x plus h minus 2 minus x plus 2 all over this whole lovely bottom of a fraction. Minus 2. And just like before, anything without an h up top should cancel. Positive x, negative x, negative 2, positive 2. And we're going to end up with h up top over h square root of x plus h minus 2, and then plus square root of x minus 2. And the reason why we didn't distribute the h is because right here, the h's should cancel. So simplifying is made easy because we don't have to do a lot to the bottom. And we have square root of x plus h minus 2 plus square root of x minus 2. And as ugly as this looks, this is the answer for the difference quotient of this function here.